find the limit as x approaches infinity of x times sine of 1 over x. All right, so the first thing we're going to do here is just plug in, in this case, the infinity, right? So once you plug in infinity, we get infinity times, well, wait a minute, the sine of 1 over infinity. Well, remember, anytime we have 1 over infinity, that's just approaching 0, right? So the sine of 0 we know is just 0. So we get this form, infinity times 0. Well, this is one of the indeterminate forms, right, that allows us to use L'Hopital's rule. But here's where you gotta be careful, right? Remember, L'Hopital's rule is used when we have a fraction, right? Like f of x over g of x. Okay, when we're finding the limit, I guess we should say, right? As x approaches some number. Okay, so if we get an indeterminate form, right, then we can use L'Hopital's rule, but it has to be in the form of a fraction. This is not in the form of a fraction, right? And we don't take the derivative using a product rule or something like that, right? So how are we gonna get this to look like a fraction? And the trick is this x, okay, this x, right? So we know that 1 over x is actually just equal to x, okay? So this is a trick that we're going to use, especially in this section, not quite a bit, right? But some here and there. Okay. So what does that mean? Well, we can rewrite this, right? We can rewrite this as the limit as x approaches infinity of the sine of 1 over x over 1 over x. And these two expressions are equivalent, right? They are the same thing. Well, wait a minute, right? We still have to check if we can use L'Hopital's rule here. Okay, well, x, if you plug in infinity here, right, same thing. 1 over infinity is about 0, so we get 0. And then same thing, right, 1 over infinity is 0. Okay, well, that's good, right? We can still use L'Hopital's rule here. So let's do that. Let's take the derivative of the numerator, the derivative of sine of 1 over x. Now remember, we got to use chain rule for this. Okay, the derivative of sine we know is the cosine of 1 over x, but we have to multiply that by the derivative of 1 over x, which is negative 1 over x squared. Okay, I'll just write it like that. Remember, 1 over x equals x to the negative first power. Okay, and wait a minute, here we go. The derivative of 1 over x is that same negative 1 over x squared. Hey, look at that, right? In this case, we don't need to plug in infinity again, right? These actually just cancel out. You do not need to use L'Hopital's rule again either, because once we plug in this infinity here, right? Remember, 1 over infinity is approximately close to 0, so we get cosine of 0, which we do know is equal to 1, right? Okay, so by determining the correct indeterminate form here, right, then we are able to use L'Hopital's rule in order to find the limit.